Hi everyone, this is going to be on expanding expressions, and I know I sound awesome today, but I need to record this video. Okay, so expanding expressions, this section really covers the distributive property as well as a couple other things. So let's go through what is the distributive property and what do they mean by expanding. So let me look at this first example. If I have 3 and then an x plus 2, so it's just my first example here. What they mean is this is the product of something because it's 3 and it's like an imaginary times there by this x plus 2. So 3 times this. This is the product, and I can actually multiply this 3 by both the x and the 2, or both terms, and make it a product or make it a sum of 2 terms. So I'm going to go 3 times x, and that's just 3x. And I'm going to bring over the plus sign, and I'm going to go 3 times 2, which we know is 6. And this is going to be the sum of 2 terms. Okay, so this had 2 factors, is another way we could call these things as well. Factors, 1 and 2. I'm going to put 2 there. 2 factors. Okay, so that's what, this is like a lot of things right here. This is expanding an expression. So I'm taking the 3 and timesing it by both and writing it like this. They're equal to each other. That's why I put the equal sign. And this could be called the product of 2 things, or 2, it's not really a term, but 2 different things. And we could call them 2 factors. So this is the product of 2 factors, and this is the sum of 2 terms. Because the sum, because we're adding them, it could be the difference as well if we had subtraction. So really we're just going to multiply whatever's outside by everything inside to expand my expression. Remember, an expression is just a term for something that doesn't have an equal sign necessarily in it. So this is also called the distributive property. I have seen it called the distributive law before as well. We're going to use this every year. This is maybe your first, seeing this, maybe a little in 6th grade with just numbers. But now we're throwing in that letter. So let's do a bunch more so you can see some different examples. If I have 5 and I have 1 minus 4c. So it doesn't matter the letter, doesn't matter if it's a minus. It wouldn't be a sum, it would be a difference, but same idea. What do I do to expand this? Well, I'm going to take the 5 times the 1, which is going to give me 5. And then I'm going to take the 5 times the 4c. Well, how do I do that? Again, I bring down the minus sign. And even though I have a number by the letter, I still just times the numbers and keep that letter. So 5 times 4 is 20. And then keep the c. So I have 20c. There's a couple different ways they show you this. They show you the 5 times 4. They show you using something called the associative property. I just thought it was a little bit confusing, but you can follow that if that makes sense. But we can just think of it as 5 times 4 is that 20 there. And this is your answer in expanded form. Let's do one that has a decimal. What if I have 0.2, move that up a little, and I want to times that by 7x minus 0.3. Again, all we're doing is timesing it through. It's a little tricky with the negative out front, but we're going to do 0.2 times 7, negative 0.2 times 7. So the way they kind of write it in the examples is they write it like this. So don't get confused. They're like, okay, just keep that x. but times those coefficients that are in front. So what is 0.2 times 7? It is going to be 1.4, and we know a negative times a positive is a negative. So the answer to this part would be negative 1.4x. Negative 1.4x. Now let's do our second term. Negative 0.2 times a minus 0.3. So I'm going to keep this minus here, and then think of it as negative 0.2 times my 0.3. So my 2 is written kind of weird. So we really, again, inside here, we have a negative times a positive, which we know is a negative. And 0.2 times 0.3 is 0.06. So this is a minus a negative 0.06. You can think of it like this. 2 times 3 is 6, but got to move the decimal 2 places. And that's where it ends up being 0.06 with those decimal rules that we have. Okay, what does a double negative really mean? In a row, it means plus. So we have to keep writing this and have it simplified to 0.06 with the plus there. So do that extra step if you have that double negative in a row to make it positive. This is our answer. Now be careful, I guess I should have said this earlier, as we go through this expanded form, you cannot add an x to a number. They have to have like letters or variables or like terms, however you've thought of that before. So I cannot combine these two here. So this is my answer here as well. Okay, so let's look at one that has the variables. So what if I have y times, oops, was this my fourth one? Yeah. This is my fourth example. So y times 2x minus 3. So this one, they have a y. What do I do with the y when I want to times it and expand it? Well, you're just going to take the y. Hopefully this button that I just laid my belly on didn't mess it up. Take that y and times it by the 2x. All that means is you're going to distribute that variable. So this becomes 2xy. We like the variables to be in alphabetical order. Bring down that minus sign. Y times 3 is 3y. So I expanded it, and all I did with the y was write it next to what was there. And that's all you have to do to expand a letter there. Okay, so what if I had a fraction? I know everybody loves fractions, right? Okay, that's a no. So when I multiply or distribute this 1/3, this fraction, think of these as over 1, these numbers, and all you do is times straight across, and then we'll have to simplify those fractions. So 1/3 times 3x. Well, think of this as 3 over 1, so 1 times 3 is 3. 3 times 1 is 3, and keep our letter, our x. We'll simplify it in a minute because we know 3 divided by 3 is 1. Bring down the minus sign. 1/3 times 9 over 1. 1 times 9 is 9. 3 times 1 is 3. Keep my letter. Okay? Oops, I put my belly on that again. All right, so then the next step here, bring down that plus sign. 1 times 2 is 2. 3 times 1 is 3. Okay, this one has an x, this one has a y, this one has just a number. So I cannot combine any of these terms. Can't combine an x and a y, and I can't combine a number with something else. So all we can do is simplify our fractions here. 3 divided by 3 is 1x, or I could write that as just x. 9 divided by 3 is 3y, and 2/3. So I can write it, I'm going to erase this instead. I can write that 1x is just x, so it's going to be x minus 3y plus 2/3 that you would write in as your solution. So even if you have 3, you can still do it the same way, distribute. And if you have fractions, don't freak out. Write them over 1 if they're a whole number, multiply straight across and then reduce. Last example, I can write my times on the other side, which is a little confusing, but it's the same thing. It's still this times this, so I can still just times by that fraction, that 1/2. Goodness, you should start to be good at 1/2. 1/2 times 6 is half of 6, which is 3. So it's kind of a cool trick. When I times by 1/2, I'm really dividing by 2. So this becomes 3a and minus 1/2 times 10b is going to give me 5b. And if you needed to put those over 1 and times across and reduce, you can. But 1/2 times something is half of it. You're taking half of it. So I just took half of both of my numbers. And that's my answer. It has an a and a b, so I can't combine them. And I just put them in as we see them there. They might show you an area model. So I'll give one more example just to make sure. So area is a great example that uses distributive. So let's say I have a rectangle. It's kind of split up here. And this one's 3.7 meters by 4.5 meters by x here, meters. And they say, okay, use the distributive property to expand the expression of the area. So the area would be length times width. And so it would be 3.7 times the width of this one is 4.5 plus x. So we could expand this after we write it out, because this is just this one plus this one, right? That's how I get there. And it's length times width. But I could just distribute this here. So 3.7 times my 4.5 is going to give me 16.65. 3.7 times x is just 3.7x. We like to write the number first, then the letter, and that's it. This is the area, either expanded or not expanded. Both are the same thing, but one is written out expanded. Okay, I hope this video helped you.